the regeneration of a green planet. If man does not convert our planet into a green planet, there will be no planet. Those are the words of Raoul Sohr, and they are no longer a warning. They are a statement of fact. For 2 centuries, the driving force behind business and politics has been greed. Extract more, earn more, consume more, externalize the cost, and call the remainder progress. But greed cannot continue if we want our planet and mankind to survive. What follows is not simply a business proposition. It is a proof of concept that goodness technologies and engineering are far more profitable than greed. That symphonic design thinking, where every element of a system works in harmony with every other, creates more value, more resilience, and more wealth than extraction ever could. We call this the constellation organizational model. Not a hierarchy, not a chain, a constellation where every node strengthens every other node, and the whole becomes greater than the sum of its parts. When we prove to business and politics that goodness is more profitable than greed, the world will convert. Not from morality alone, but from logic. This is that proof. In 1895, Nikola Tesla stood before the world and declared that the energy of the future would come from water. He envisioned a civilization powered not by burning fossil fuels, but by unlocking the elemental forces within water itself. For over a century, that vision remained a dream, brilliant but unrealized. Today, we stand at the moment Tesla foresaw. What you see before you is not merely a hydrogen initiative, nor is it simply an agricultural project. It is the Goodness Cluster, a closed-loop, sovereign-scale industrial platform designed to deliver national energy security, food resilience, and economic transformation. And it begins just as Tesla imagined, with water. Technology Foundation, the modular mobile hydrogen factory. To understand the geopolitical significance of this platform, we must first understand the technology that underpins it. For more than 50 years, hydrogen has been the energy industry's great unfulfilled promise. The chemistry works, the economics have not. Conventional electrolyzers typically require around 50 kilowatt-hours of electricity to produce 1 kilogram of hydrogen. At normal grid energy prices, this pushes delivered hydrogen costs into a range that cannot compete commercially with gasoline, diesel, or industrial fossil fuels. The modular mobile hydrogen factory changes that equation. MMHF is a proprietary, self-contained hydrogen production platform designed to produce zero-carbon hydrogen at a target cost of below $2 per kilogram. It requires no grid connection, no renewable energy dependency, and no fossil fuel input. This primary input is potable water. The systems are modular, mobile, and deployable across multiple configurations. From compact fridge-sized units producing 5 to 10 kilograms per hour, through to secure 20-foot and 40-foot containerized units capable of producing up to 240 kilograms per hour. Multiple units can be clustered to match the hydrogen demand profile of each customer, site, port, mine, data center, military base, or industrial facility. Each unit is designed to be secure, AI-controlled, fully automated, and self-contained. Transported by truck or rail, deployed directly to site, commissioned rapidly, with the objective of becoming operational within a single day. In effect, MMHF transforms hydrogen from a centralized, infrastructure-heavy commodity into a mobile, sovereign energy asset. The strategic advantage of the MMHF is its form factor. The modular container is the asset. It does not require a decade of environmental impact assessments, billions in capital expenditure, or massive grid connections. It requires only water and a footprint. A container producing 30 kilograms of ZCH2 per hour translates to 500 kilowatt-hours of zero-emission power. At full scale, the MMHF delivers electricity to match fossil fuel energy cost. And here is the critical distinction. The MMHF is self-powered. It captures 3% of its own hydrogen output and feeds it through an internal fuel cell to run the entire system. No external power source is required. When a client needs electricity, The hydrogen is pumped through an external fuel cell, or the hydrogen goes direct into a converted gas generator. Furthermore, unlike wind and solar, which deliver intermittent energy dependent on weather conditions, the MMHF produces electricity 24 hours a day, 7 days a week. This makes it a true baseload power source, capable of feeding directly into national grids as reliable, continuous supply. One of the most transformative features of the MMHF is that it eliminates the entire hydrogen supply chain. The unit is deployed directly on the client site, producing zero-carbon hydrogen on demand. Consider what this means. Traditional hydrogen delivery requires compression to 700 bar, specialized tanker trucks, complex storage infrastructure, and a logistics chain that adds enormous cost and risk. Our model removes all of that. The MMHF sits on your premises, connected only to a water source. It produces exactly the volume of hydrogen you need, precisely when you need it. Zero transport, zero storage, zero supply chain vulnerability. This on-site, on-demand model fundamentally changes the economics of hydrogen adoption. It eliminates the single greatest barrier to the hydrogen economy: the cost and complexity of getting hydrogen from where it is made to where it is used. With the MMHF, those two places are the same. The hydrogen industry has long relied on a color-coded taxonomy to classify production methods. Black and brown hydrogen from coal gasification, gray hydrogen from steam methane reforming, blue hydrogen which adds carbon capture, green hydrogen from renewable-powered electrolysis, pink from nuclear, turquoise from methane pyrolysis, and white hydrogen naturally occurring underground. But color tells you nothing about actual environmental impact. What matters is carbon intensity, the kilograms of CO2 equivalent emitted per kilogram of hydrogen produced. Let us examine the data. Black and brown hydrogen, produced from coal, emits approximately 22 kilograms of CO2 per kilogram of hydrogen. Gray hydrogen, the most common form today, emits 13 kilograms. Turquoise hydrogen emits around 4 kilograms. Blue hydrogen, despite its carbon capture systems, still emits 3.5 kilograms due to upstream methane leakage. Green hydrogen, often presented as the gold standard, still carries a life cycle carbon intensity of approximately 2 kilograms per kilogram of hydrogen, accounting for the manufacturing and disposal of solar panels, wind turbines, and battery storage systems. Pink hydrogen from nuclear sits at 0.8 kilograms. White hydrogen extracted from geological formations at 0.5. And then there is ZCH2 zero-carbon hydrogen from the MMHF. 0.0 kilograms of CO2 per kilogram of hydrogen produced. Not low carbon. Not near zero. Absolute zero. The MMHF requires no external energy input, no fossil fuels, no renewable infrastructure. It is entirely self-powered, producing hydrogen from water alone. And it does so at a cost of 50 cents per kilogram, a fraction of what green hydrogen costs today. This is not an incremental improvement. This is a category of one. To deliver 5,000 clusters, we must first build the machines that build the machines. Our plan is a network of 500 MMHF production hubs distributed across the African continent. Each hub is a 10-gigawatt automated assembly facility, producing MMHF units at industrial scale. These are not foreign-owned assembly plants. They are African manufacturing facilities, staffed by African workers, both skilled technicians operating robotic assembly lines and manual laborers handling components, welding, testing, and commissioning each unit. Each production hub creates thousands of permanent manufacturing jobs. Engineers, robotics operators, quality control specialists, welders, electricians, logistics coordinators, and maintenance teams. 500 hubs means hundreds of thousands of manufacturing jobs. A new industrial workforce built from the ground up. This is sovereign manufacturing. Africa does not import its energy future. It builds it. Because the asset is modular, the economic model is infinitely replicable. We are not proposing a single megaproject. We are building multi-grid microgrids to assist national grids as baseload or as standalone power sources. Our rollout begins with operational clusters in South Africa and Latin America, expanding to contracted sites across the USA and Africa. Our target is 5,000 operational clusters by 2028. This represents a distributed network of sovereign industrial platforms, each producing its own bankable cash flow, reducing national import dependency and generating wealth from within. Africa possesses vast arable land and abundant labor. What it has historically lacked is reliable, affordable energy to power modern agriculture. The MMHF changes this equation. Each cluster powers a 1,000-hectare organic agricultural operation centered on sugar beet, specifically bred for tropical and subtropical climates. The sugar beet we cultivate produces BRICS 65 bio-sugar, a premium, organic, non-chemically produced sweetener that commands significant price premiums in global markets. But the agriculture is not limited to sugar beet. It is the anchor crop within a diversified, regenerative system. We do not engage in extractive monoculture. Our agricultural model is built on regenerative polyculture, a system where every crop strengthens the soil for the next. Sugar beet is the anchor, but it rotates with sunflowers for oil production, legumes for nitrogen fixation, and cover crops for soil restoration. The result is a system that improves year on year, building topsoil, sequestering carbon, and eliminating the need for synthetic fertilizers or pesticides. This is certified organic agriculture at industrial scale, powered entirely by zero-carbon hydrogen energy. For sovereign partners and development finance institutions, the employment numbers are transformative. Each cluster creates over 3,000 direct permanent jobs: field workers, agronomists, processing technicians, logistics operators, engineers, and maintenance staff. At scale, 5,000 clusters, this platform generates over 10 million direct jobs across the continent. These are not temporary construction roles. They are permanent, skilled positions in a system designed to operate for decades. This is sovereign industrialization through employment. The agricultural output of the cluster is not a bulk commodity. It is a premium, certified non-GMO bio-sugar, BRICS 65. This is a cold-pressed, crystallized sugar produced entirely from non-GMO sugar beet, with no chemical processing, no bone char filtration, and no synthetic additives. BRICS 65 commands a wholesale price of approximately $900 per ton, a significant premium over conventional refined sugar. It is certified non-GMO, vegan, and halal. It meets the sourcing requirements of every major food and beverage company on Earth. The market demand for this product is immense and structurally guaranteed. The global sugar market exceeds 180 million tons per annum, yet non-GMO sugar represents less than 1% of supply. Demand from multinational food and beverage companies for certified non-GMO sweeteners is growing at double-digit rates annually. Our offtake structure is designed to de-risk the investment from day one. We are in advanced discussions with global brands across 5 categories: food and beverage manufacturers, pharmaceutical companies, cosmetics firms, biofuel producers, and industrial chemical buyers. This brings us to the final element of the closed loop. The same hydrogen that powers our farms and processes our sugar also fuels the trucks that deliver it. Zero-carbon hydrogen logistics, from field to customer, with no fossil fuel input at any stage. We are partnering with fleet operators to retrofit existing diesel trucks with hydrogen fuel cell powertrains. The economics are compelling. A retrofitted hydrogen truck delivers lower cost per mile than diesel within the first year of operation, with zero tailpipe emissions. The transition to hydrogen logistics is driven not by environmental aspiration but by unassailable unit economics. When hydrogen is produced at under $1.50 per kilogram, the fuel cost per kilometer falls below diesel. Factor in the elimination of carbon taxes, reduced maintenance costs from simpler drivetrains, and the premium brand value of zero-emission delivery, and the business case becomes overwhelming. This is not a subsidy-dependent transition. It is a market-driven inevitability. The global demand for data center capacity is growing exponentially, driven by artificial intelligence, cloud computing, and the digitization of every industry. By 2030, data centers will consume more than 10% of global electricity. The industry faces a crisis. Where will this power come from without destroying the planet? The MMHF provides the answer. Deployed on-site at hyperscale data centers, our units deliver continuous, reliable, zero-carbon electricity at 5 cents per kilowatt-hour. No grid dependency, no intermittency, no carbon footprint. For data center operators facing both energy costs and ESG mandates, this is transformative. The cryptocurrency mining industry faces an existential challenge: its energy consumption. Global mining operations consume more electricity than many nations, and the carbon footprint has become a reputational and regulatory liability. The MMHF offers the world's first truly zero-carbon mining solution. By deploying MMHF units directly at mining facilities, operators receive continuous, low-cost electricity with zero emissions. At 5 cents per kilowatt-hour, the energy cost is competitive with the cheapest hydroelectric sites on Earth, but without the geographic constraints. Mining operations can be located anywhere there is water. The environmental narrative transforms from liability to leadership. The infrastructure for the hydrogen economy does not require billion-dollar pipeline networks or centralized production plants. It requires what we have already built: modular on-site hydrogen production. Our vision is a network of hydrogen refueling stations, each powered by MMHF containers producing ZCH2 on-site and on-demand. No hydrogen needs to be transported. No compression infrastructure is required beyond the dispensing point. The station simply connects to a water supply, and the MMHF does the rest. This model can be deployed at existing fuel station sites, logistics hubs, port facilities, and motorway service stations. It is the infrastructure backbone for the next generation of zero-carbon logistics. Now imagine taking this technology to sea. The maritime shipping industry accounts for nearly 3% of global carbon emissions, more than the entire aviation sector. International regulations are tightening, and shipowners face enormous costs to comply. The MMHF offers a radical solution. By installing MMHF units directly on board vessels, from cargo tankers to luxury cruise liners, ships can produce their own hydrogen fuel from the very ocean they sail upon. Seawater is drawn in, desalinated on board, and fed into the MMHF. The hydrogen produced powers fuel cells that drive electric propulsion. The vessel becomes entirely self-sustaining. No bunker fuel, no port refueling, no emissions. From ocean to power, the ultimate closed loop. Looking further ahead, the implications for personal and commercial transport are profound. The vehicles of the future will not carry heavy batteries or stop at charging stations for hours. They will carry a simple 70-liter water tank. A miniature MMHF, no larger than a briefcase, will sit under the bonnet, continuously converting water into hydrogen. That hydrogen feeds a fuel cell connected to electric motors at each wheel, providing instant torque, zero emissions, and a range limited only by the nearest water tap. Cars, trucks, lorries, buses, each with their own self-contained system. No external fuel required. This is not science fiction. The core technology exists today in our industrial MMHF. The miniaturization pathway is clear. Just add water. Africa holds 30% of the world's mineral reserves, yet the continent captures less than 5% of the value from those resources. The reason is simple. Mining and processing require enormous energy, and that energy has historically come from imported diesel and coal. The MMHF changes this equation. By deploying clean hydrogen power directly at mining sites, we enable zero-carbon extraction and processing. But this is not just about decarbonization. It is about job creation at scale. Each MMHF-powered mining cluster creates thousands of permanent jobs: operators, technicians, engineers, logistics workers, and processing staff. Clean energy mining becomes the engine of sovereign industrialization. The European Union's Carbon Border Adjustment Mechanism (CBAM) is now in force. It imposes a carbon tax on all imported goods based on their embedded emissions. For African nations exporting raw minerals processed with fossil fuels, this represents a devastating trade barrier. The MMHF eliminates this barrier entirely. When minerals are beneficiated on-site using zero-carbon hydrogen power, the embedded emissions drop to zero. The finished product, whether refined metals, processed alloys, or manufactured components, enters European and global markets with full CBAM compliance. No carbon border tax, no trade penalty. This transforms Africa from a raw material exporter into a competitive, value-added industrial producer. The aviation industry has committed to net zero by 2050, but it has no viable pathway without sustainable aviation fuel. Current SAF production meets less than 1% of global demand, and costs remain prohibitively high. ZCH2 hydrogen is the critical feedstock for next-generation SAF production. Combined with captured CO2 in a Fischer-Tropsch process, our hydrogen produces synthetic jet fuel, a drop-in replacement that is chemically identical to conventional kerosene, but with near-zero life cycle emissions. Our strategy is to co-locate the SAF production facilities at landfill sites across the country to capture the CO2. Now we have created an integrated, low-cost supply chain of billions of liters of SAF for the aviation industry's most urgent need. Steel production accounts for 7% of global carbon emissions. The industry knows that hydrogen direct reduction is the only viable pathway to decarbonization, replacing coking coal with hydrogen as the reducing agent in iron ore processing. The challenge has always been the cost and availability of green hydrogen. The MMHF solves both. Direct from the MMHF, the hydrogen makes direct reduced iron economically competitive with conventional blast furnace steel. Deployed at the mine mouth, the MMHF enables nations to produce low-carbon steel directly from their own iron ore, capturing the full value chain from extraction to finished product, all with zero carbon emissions. Cement and ammonia are two of the world's most essential industrial products, and two of its heaviest carbon emitters. Together, they account for more than 10% of global CO2 emissions. The MMHF addresses both. In cement production, MMHF hydrogen provides the high-temperature heat for the kiln process, replacing coal and natural gas. The result is zero-carbon cement. In ammonia production, MMHF hydrogen replaces gray hydrogen derived from natural gas in the Haber-Bosch process. The result is zero-carbon ammonia production under $150 per ton. Ammonia is essential for fertilizers, industrial chemicals, and increasingly as a clean fuel for shipping. By decarbonizing these foundational industries, the MMHF platform addresses the hardest-to-abate sectors of the global economy. Beyond industry and commerce, the MMHF serves a profound humanitarian purpose. Across the developing world, remote and rural communities remain entirely disconnected from national power grids. Island nations face crippling energy costs importing diesel by sea. And when natural disasters strike, earthquakes, floods, hurricanes, existing power infrastructure is the first casualty and the last to be restored. The MMHF addresses all three scenarios. In remote rural locations, a single container provides reliable, continuous power to entire communities, powering hospitals, schools, agricultural cold storage, and local commerce. For island nations, the MMHF eliminates dependency on imported fossil fuels, producing clean energy from locally available water. And in disaster recovery, the MMHF becomes a rapid deployment lifeline. Within hours of an earthquake or flood, containers can be transported to affected areas and commissioned immediately, restoring power to emergency shelters, medical facilities, water purification systems, and communication networks. This is not just an industrial platform. It is a sovereign resilience tool. To scale this platform, we have designed a capital structure that is both institutional grade and sovereign aligned. The holding company is a Delaware-incorporated entity that serves as the master franchisor and technology licensor. Each cluster operates as an independent special-purpose vehicle with its own audited financials, local equity participation, and ring-fenced cash flows. The fund structure is designed for sovereign wealth funds, development finance institutions, and institutional investors. It offers infrastructure-grade returns with contractual offtake, hard asset backing, and carbon credit revenue. The target fund size is $500 million, deploying across the first wave of clusters. Why is this possible now? Because three macro forces have converged simultaneously. First, the technology is proven. The MMHF has moved from laboratory to production. The unit economics are audited and bankable. Second, the regulatory environment is aligned. Carbon pricing, CBAM, and national hydrogen strategies across Europe, Africa, and the Americas have created a policy framework that rewards exactly what we produce. Third, the market demand is structural. Global brands like Coca-Cola, Pepsi, Cadbury's, and Nestle are contractually committed to decarbonizing their supply chains. They all need a non-chemically produced sugar, zero-carbon fuel, and zero-carbon logistics. We provide all three. Our vision is clear. Once Cluster 1 is operational and producing audited financials, the unit economics become a proven template. By 2028, we envision multiple thousands of clusters operating across North and South America, Africa, Europe, and Asia. This is a network of clean energy, clean industry, and clean logistics, feeding global supply chains and generating sovereign wealth from within. It is a constellation of closed loops, entirely independent of fossil fuel volatility and extractive economics. To execute this vision, we are advancing 6 concurrent strategic tracks. We are securing power purchase agreements from anchor offtakers like governments, mining houses, and many industrial global brands. We are raising $40 to $60 million in pilot cluster capital. We are establishing strategic partnerships with OEM and retrofit leaders. We are securing letters of interest from development finance institutions. We are identifying a cornerstone limited partner for the fund. And crucially, we are seeking sovereign mandates from host nations to facilitate land tenure and regulatory integration. We began with a vision that Nikola Tesla articulated over a century ago, that water holds the key to limitless energy. Today, that vision is no longer a dream. It is an engineered reality. From water, we produce hydrogen. From hydrogen, we produce power. From power, we grow food, we fuel transport, we smelt steel, we produce cement, we power data centers, and we propel ships across oceans. The loop closes. The wealth stays sovereign. The work begins. Thank you for your time, and we welcome your strategic partnership. Pierre Teilhard de Chardin wrote, "If man does not invent goodness technologies, mankind is doomed. You have now seen the proof. From water, we produce hydrogen. From hydrogen, we produce power. From power, we grow food, we fuel transport, we smelt steel, we produce cement, we power data centers, we propel ships across oceans, and we regenerate communities. Every element in this system strengthens every other. Every cluster is a node in a constellation. Every nation that joins becomes stronger, more sovereign, more resilient. This is symphonic design thinking made real. This is the constellation organizational model in action. This is goodness technologies replacing greed as the driving force in business and politics. Not because we ask the world to be better, but because we prove that goodness is more profitable. The regeneration of a green planet begins here. The loop closes, the constellation grows, and mankind endures. Thank you.